can you show me? I want to see my chat. Yeah. No. Yep. Thank you. Here.
Yep.
All right. How are we? Can we hear anything now? Sound. Okay, excellent. Sound's there. You're lucky you get to see me from down below, so you get to see like 3 chins, so enjoy that. I've never, look at this, someone saying their ears are blessed. No one has ever said that to me when I've started talking. I've got a very grating voice usually. Okay, let's do it. Okay, we are ready to go. Linked lists. Okay, so last week I was away and you guys were so lucky you got to do pointers and then you got to start linked lists, which I hear there was a lot of excitement about. Maybe that was just fallacy over here being told to me. So what we're going to do today is we're going to go over linked lists again because they're pretty important things, pretty important data structure that we really want to understand and to know well. I'm going to draw some things for you, hopefully, well, a linked list. I'm not really going to draw random things for you that you kind of asked me to draw because then you'd be very disappointed in my artistic skills. And we are going to maybe get as far as we can. Apologies, it took 30 minutes to fix some of the issues. So we're going to try and get through as much as possible, but don't worry because on Thursday we've got time to catch up and I'll do a shorter lecture program if I have to and move things into week 9 if I have to. And we can just cut a few things as well if we need to that will not be examinable if we run out of time. So don't worry. We will do a good recap and we will go through it all again. Also, I noticed, just quickly, I'll address it so that everyone is aware of what's going on. There have been a few questions about the exam. We will be going over in detail what the exam is, when is the exam. We'll do the admin, the housekeeping side of things on Thursday next week. And then we're going to have week 10 as our revision week. You would have seen on your timetable that the exam is scheduled over a few days, and I think the timetable, the final one came out today, even as we're still debating what should we do. And that's because there is too many people in this course to be able to fit into one session. So there's going to be a few sessions for this exam, and you will get, I think there's 2 sessions on one day, and there's 1 more session on another day. You will be getting different exams on those 2 days, and you will be corralled between the morning and the afternoon session as well. And we'll talk more about that. And there's going to be a preference that you can nominate which day or which time you would like to sit the exam, and first in, best dressed kind of thing. So that's how that's going to work. And we're going to talk a lot more about the exam next week on Thursday, because Monday is a public holiday where we're going to learn no new information, so give you a bit of relief. Also, I'm sorry, the computer is using my camera, so I've just realised that I'm constantly walking out of the shot. Okay, so...
Sorry, we need to double mic you, we'll get you back online.
Oh, well, it's streaming, I'm streaming, so I'll just go like this for the rest of this until the break time, and then we'll change the streams, because it's just, sorry, it's, yeah. I actually don't need this microphone right now because it's picking up from my computer. But I've got a very loud voice. You can hear me, can't you? Can you hear me at the back if I don't use a microphone? Yeah, I can project. Okay, the final exam is going to be during the exam block, okay? So it's going to be, I think Tuesday is the first day of it in week 12. And then there's going to be another day. So anyway, we'll talk more about it in week 9. Let's do linked lists. All right. What is a linked list? Who knows what is a linked list? Anyone? No one knows what a linked list is. It's a list. It is a list indeed. What is it a list of? Is it a list of nodes? It is a list of something. It's a list of some data. What is so special about a linked list? How do I know that I've got a linked list? Yeah, okay. I've got a few comments coming, so I know that it's a linked list because it points me to the next thing in the linked list. So the one special thing about a linked list, when we learnt about arrays, we learnt that arrays they come one after another, each index of the array, and in memory they're stored right next to each other, which means it's an index data structure. So I can access anywhere. If I know where it starts and I know how many elements are in that array, I can go anywhere just by using the index of the element that I want to access. Now a linked list is not like that. A linked list is a dynamic structure. And what that means is that since it's a dynamic structure, and let's say this is my memory, what I can do is every time that I need a node, every time if I don't know how big a list I want to make, I can make this memory at runtime and I can keep adding to it. I can keep building a node as I need it. So I can get a node here, and then a node here, and then a node here, and then a node here, and maybe one here. Now, that's great for me that I can just kind of, have many nodes everywhere. But there is no way for me to know where on earth these nodes are if I just put them randomly in my memory. Whereas an array used to be something that looked like this and meant that if I know the first thing, I'll know all of them because I can access them one by one and they're stored consecutively in memory. So a linked list is not like that, which means that not only do I need to store some type of data in that linked list, but I also need to store the address of the next thing so I can somehow find where on earth I need to go to next. So what that means is that each node has to hold two things, or it can hold more things than that, but it must have at least two things in it. And those two things would be some sort of data, and I can have different types of data. I can have an int or a char or really whatever you want. And then I need to have a pointer to the next element because I need to know where on earth my next node is stored. So it's kind of like a scavenger hunt. If you know where the first thing in the list is, then each time you might have a pointer to the next address. So when we build our node up, what it looks like, let's say this is our struct node, and we're going to hold it in a structure because we want to be holding together different data types. We're holding together. In this case, I'm going to use an int just because it's an easy one to demonstrate, but you can have different things. So let's say I want to have some sort of int data, which means that if this is my struct, it's going to have some sort of data in here. And then what I want to do is I want to be able to create a pointer to my next node so that I can find the next node. Otherwise, if I don't just have the data, I can never actually link up my different data points together because I don't know where on earth they are stored in this mess of memory. So what that means is I'm going to have a pointer in here, and that pointer has to point to the next node, and that means that the pointer is going to be of type struct node, and you'll often see it called next, okay, because it's the next thing in the list. So that means in a struct node, there's going to be at least two of these things, and you can have more and you can have different types. But what makes it a linked list is that you always have a pointer to the next item, to the next node. That's what makes it a linked list. Now, I saw a few people on the forums asking, oh, you can have a double linked list, you can have a circular linked list, you can have all sorts of things. In 1511, we will only learn a single linked list, which means we're going to go one way through. And that means that I'm going to go in one direction only. So I'll start at the start, and then I'll go to the next one, and the next one, and the next one, and the next one. So if I were to build up a linked list, okay, and I'm going to build it up for you. Okay. Let's say I have my first node. Now, who knows what the first node is usually referred to as? Yeah, the head of the list. We start at the top, we move to the bottom to the tail. So the first node is usually called the head. So let's say this is going to be my first node in the list. It's going to be head. And let's say I'm storing items 3, 4, and 5 in my linked list. So what will happen is inside my head, which is the first element in my linked list, I'll have the item 3, which is my int data, and then I need to somehow have another node, and that node is going to have the 4 in it, and then I'm going to have another node, which is going to have the 5 in it. Okay, fantastic. Right now, those nodes are not linked up together in any way, which means I need a way to be able to link them up and to make them into a list. So each one of these pieces of memory, each place where this struct node is created, anytime I create any variable, I have to place it into a piece of memory. So these memory addresses right now are going to be completely made up, but let's say this one is sitting inside FFF, this one is sitting inside 1FF, and this one is sitting inside 2FF. Okay, great. That means that my first pointer, the head of the list, is going to be sitting at this address. So if I create a pointer, my head is going to have the address inside it, and that head is going to have this address inside it, which means I will know where my list starts. Now, if I want to go from 3 to 4, as I did in this list, so if I want to go from here to here, that means I need to have a next over here that points to the address of the next node. And that means it's going to be a pointer, because I need to store an address, and it's going to go to 0x1ff, which means that this address is going to point to this node. Then if I want to go to the node with 5 on it, I'll go to the next address where that 5 is stored, so 0x2ff. And that means that it's going to point to this one. Now when I get to the end of a linked list, to know that I'm at an end, I don't just go, all right, well I'm at an end, there's nothing there, fantastic. Who knows what I do to say if it doesn't point to anything, where to signal that it's the end of the list? No, exactly. So when you get to the end of a list, oh, that's 3 L's, that's interesting, good spelling. I bagged you out for your spelling, then I spell null with 3 L's. So when you finish a linked list, it goes to null, which means that I've reached the end of a linked list. Now there is no way, like in an array, you can say, okay, give me something at index 2 or give me something at index 3. I can't do that in a linked list. I have to start at the top and move through it until I get to whatever element I want. And I have to be careful to not go past the end of a linked list, because otherwise I'm trying to dereference something that doesn't exist, so a piece of memory that's not there. Okay, so if we look at the piece of code that you guys wrote in week 7, and if we go through that piece of code, okay, someone's asked a great question, is null automatically included at the end of the linked list? It is not. It's something that you initialize, and something, because you are the one that's creating a linked list and you are taking the memory as you need it. Because you are creating the memory as you need it, you are the one that's saying, okay, this is the end of my list, which means that my last node is going to point to null, and so on and so forth. So let's have a look at the piece of code that you wrote on Thursday of week 7, and then we can go through it and draw it out what it's actually doing. Okay, let's erase this. Okay, I've tried to start going through it and just writing some notes for you, and I'll keep doing that now as we do it. Okay, so first things first. When we have our piece of code here, we include our libraries. We include standard library because that's the library that mallocs and frees. And we need to, because we're building up our linked list as we go on a per need basis, so we're taking the memory when we need it as opposed to allocating it at compile time, we're going to use malloc. Okay, so that's the memory allocation function. Whereas in an array, you say what size you want the array to be straight up, you declare that, and that piece of memory is given at compile time. So this is no longer happening. You don't have to say how long you want your linked list to be. You allocate the memory on a per need basis, which means that you use that malloc and free functions. Okay, so if you use a linked list, then you're going to define your structure. And each linked list is made up of the different nodes that is going to make up the linked list. So you will have your struct node, and inside it I'm going to have an int data, And again, it can be a char data, it can be a string, it can be whatever on earth you want, okay? You can have multiple things in there that you're storing as well. It doesn't have to be just one thing, but this is the simplest thing to demonstrate, and we're going to do a harder one on Thursday, hopefully with time. So we're going to store some type of data in the linked list, and what we're going to do next is we are going to have a pointer called next, and that pointer is going to point to a type struct node. And the reason for that is, if you remember, if I want a pointer to point to, so if I want a pointer to point to an int, then I would declare it by saying int star pointer is equal to blah, blah, blah. Now, in this case, I want that pointer to point to another node, which means the type is going to be struct node, and then whatever on earth I'm going to call it. So it's going to be a struct node pointer, because it's pointing to another struct node. And that's what's going to allow you to connect up your linked lists of the multiple nodes as well. So we've got our struct node, which is really the structure that we use to compile our linked list. Now, you also wrote 3 functions. You wrote a function that will create a node, so something that will build a node from scratch, which means it will give some memory. It will take some memory, malloc some memory. You'll initialize whatever you want that node to hold, so you will initialize it to a value inside the data, and you'll also tell it what you want to be the address of the next node. And that's why this function is going to take in 2 arguments. It's going to take in the data that you want to put into the node, and it's also going to take the address of the next node when it's creating a node. So it's got everything that it needs to initialize a new node. And what it's going to return is it's going to return that node to you. But it's going to return a pointer to that node that it's created, which is why you're returning a struct node pointer. Then you did a function that is going to print some nodes, and then all you need to give that function is the head of the list, because once you have the head, you can just traverse through it until you get to null. You don't need to know how many things are in it. You just traverse through it till you hit null and print out each single node. And you don't return anything from it because you're just printing out the values in each of the nodes. Okay, and then finally, you made a way that you can actually build up your list. So you've got a function that adds nodes to the end of the list. And what you're giving it is you're giving it data, and you're giving it what's going to be you're giving it the head of the list, and you're giving it the data that you want to add. And then you're giving it where to actually start looking for this linked list. And again, you can traverse that linked list until you find the end of it, and then insert that piece of data in. And again, what you will return from it is going to be a pointer to a struct node. Okay, so let's go through this code. What I'm going to do is I'm going to change some of the variable names to different names because I feel like it, and because I think maybe it might make more sense. And what I'm going to do is, I know you did a student number example. I'm going to go back to simple numbers to allow you to actually see what's being created a little bit easier potentially. Okay, so let's go through this code. Okay, so the first thing we're doing here is creating, and now this is going to lead to mistakes, so just bear with me when I compile. So the first thing I'm going to do is I'm going to have a pointer that is going to point to a struct node, and I'm calling it head because it's going to store the address of the head of the list. Okay, so it's going to be a struct node pointer, and I'm going to call it head. What I'm going to do then is I'm going to assign that head, I'm going to initialize it to null. Okay, so what that means is the address of that head is currently null because I haven't done anything. I haven't given it an address. I haven't malloced any memory for it. So right now I have given it a null. I've initialized it to null. Okay, so now I actually want to do some stuff. Okay, so I'm going to say that my head, and remember I'm going to use this function here, add node end of the list. This function returns to me a struct node, and what I'm going to do is I'm going to say head is equal to add node to the end of the list, and let's say I'm going to add the number 3 to it, and I'm going to give it the head of the list. Okay, so what that means I've done is I have said head is equal to, I'm going to call this function, I'm going to give it the data 3, and then I'm going to give it whatever is happening, the address is null right now. Okay, so let's go down to add node end of the list, and we will go through it. Okay, so what is happening is this lovely function is getting the data 3, and it's getting a null over here. So that means right now when I call this function, my data over here is equal to 3, and my head is equal to null right now. 3 L's, I don't know. It's calling me to spell it with 3 L's. I don't know why. Okay, great. So first thing, on line 40, if head is equal to null, which it is right now, I have no list, I have nothing going on. So head is equal to null, that means I'm going to go inside this if statement, and I'm going to return create node data null. My data right now over here is 3, which means that I'm now going to call the function create node, and I'm going to call it with 3 and null. Okay, so if I move up a little bit to my create node function, here it is. Okay, so I'm now calling this function, and I'm calling it with data 3, and this equals to null. What it's going to do is it's going to create a pointer node, an address to the head, I imagine. Okay, so right now that means I've got a pointer here called SPTR, and we can change the name of it, don't worry. It's currently not equal to anything. I haven't initialized it to anything, but I've created it. Then on line 63, what I'm doing is I'm actually giving it something now. So I'm calling the malloc function, which means that I would like to say birthing it, but that is so weird. That is the weirdest. I'm giving it some memory, and I'm giving it the memory of size of struct node. What that means is that it's getting the size of a struct node, and my definition of a struct node right now has an int data and a struct node next, okay? Which means it's created, this is creating for me is somewhere, let's say this is my memory, it's like, oh, where is a free spot? Maybe somewhere here. I'm going to create a node here, and it's going to have a size of a struct node, which means that it's going to have a node, and it's going to have some int data here and a pointer here. So it's going to have a pointer next here and a data over here, and this is going to be called SPTR. Okay, great. So now I've created this lovely blank node. It's got nothing in it, and what malloc has returned to me is it has returned the address of this node that it's created, of this piece of memory that it has created. Which means that if this node was created at 0x000, again completely made up, what it means is that my SPTR pointer is now going to have that address in it. Okay, so I've malloc some memory, I've created this node, and I've assigned where I've created that memory to my pointer SPTR, because otherwise I'd lose that piece of memory. I don't know where it's created, so I want to know where on earth it is. Then what I'll do is I'll say, okay, SPTR, access the data part of that struct, and that means I'm going to access inside this node, I'm going to access the data element, which means I'm accessing this member of the structure, and I'm going to assign data to it. Data is currently equal to 3, which means 3 is going to go in here. And then I'm going to initialize the next component. So I'm going to again go inside my SPTR node, I'm going to go into the next element, so I'm going to access the next member, and then I hate these rooms. I hate them. I don't get it. Why did it just switch off? And it says room lights on. It's not even, I haven't touched anything. Okay, and I'm assigning to it the value of next. The value of next is over here, and it's null because that's what I passed into this function, which means that this is now null. And I like to draw it out so that I can see where it's ending. So that's kind of really what it looks like. And null means it's not pointing to anything. There is nothing there. And then what I do is I return SPTR, which means I return this memory address because it's a pointer. So this memory address is now heading up to where I called it from, and I called it from here. So I've returned that memory address here in this create function, and I'm going to return it back to here just to make it even more confusing. So I'm going to return it up to here. It's now the head of the list, okay? So this is now the head of the list, and I am now ready to potentially do something else. Okay, fantastic. So I've got that. So now let's see what we're going to do next. I've got one node that I've just created. And this is similar to your assignment 1.1, where you literally have to create that, a node. You have to create a node, which means you've got to get some memory for it, and then you've got to assign some values to it and return it. Okay, so next thing is next. What will I do next? I'm going to call it over here. Okay, since I started changing everything to head, let me go head again. And I'm going to go, value 5. Why not? Okay, so what I'm doing now is the address of whatever this node is now in the head, which means that I've got my head over here for this function inside main. So this is inside main. My head is currently equal to wherever this node was, which was inside 0x000. Excellent. So now I move to line 32 and I say, okay, I want to assign head and I want to call the function add node end of the list again, and then I want to do that again. Okay, great. So remember, we do the right side first. So I'm going to look in here. I'm going to go to add node to the end of the list. So I'm going to go down to the function that adds node to the end of the list. And I'm going to go in here. Great. Okay, that means I have passed it some values. And what have I passed it? I've forgotten already. I think it was 5. And I've passed it the head. So the address is 0x000. So I've passed it this address. Okay, so now it's going to say if head is equal to null. Well, it's not equal to null. It's got an actual value assigned to it, which means I don't go inside this if statement. So I'm going to pop down to line 43, and I'm going to start going through here again. Okay, I'm going to create a struct node, a pointer to a node again, and this is now inside add node function, so new function. I've got now a pointer P to a struct node. Over here, what I've done is, oh my gosh, I'm going to change these variable names. Okay. It's hard to understand when you're just learning. Okay. What I'm going to do is I'm going to create a current pointer. And what it allows me to do is it allows me to keep track of where I am in the list. So hang on, give me 2 seconds. Sorry. Okay, here we go. All right, so what I'm going to do is I'm going to create a pointer called current, and I'm going to assign the value of head to it, which means that I'm going to assign 0x000 to it because that's the value that I was given. Now, why do you think I need this pointer? Why do I need this current and then I'm going to assign head to it? Why don't I just use head? I already have the value of head. Why don't I just use head? Thoughts? Exactly. So if I use my head and I start moving through the list, I'm going to lose the value of where on earth this list starts. Okay? So I don't usually touch the head. I keep it separate in a treasure chest, and what I do is I create another pointer that has the same address as the head, and that's the one that I play around with. That's the one that I can do whatever with, and that means that the value of the start of the list is still safe. It's not modified in any way, which means that I don't lose it, because if I lose that first bit, if I lose the head, I will not be able to get anything in that list or find anything. Yeah?
So So if you pass in a pointer that's called head, if in the function definition you define it as expecting to receive a parameter called head, right? So when you receive the actual value of head, right? Technically, you're not getting the same exact point, right? You're getting the value of the memory address that it points to. So if you were to change head within the function, that wouldn't change the main function's head pointer value, right?
Yeah.
But then if you were to refer to head inside the thing, you would obviously change that same memory address.
Yeah.
So then technically here, it's not, since you're only incrementing, or you're just changing the memory value that it points to, technically you can actually use head.
So
right?
technically, yes,
But
across the different functions, you're right. The values are copies that you're passing in, right? But the copy is an address of a pointer. So if you then pass, so if I then return that head that is now happening, that's going to have a different value. And if I assign it, the way the code is written here, if I assign it to the head, that means I've changed my other head as well now, which is fine. So hang on, I'll do it. I'll do it in a second.
Okay.
But yes, you are right. Technically, I could just move around with the head and it's not affecting my main function. It's got the address, but it depends what I do. But it's good practice to not do that because you will get lost amongst, you're going to have more than one function, more than two functions, more than three functions.
Technically, as long as you don't dereference, it should be fine. But in this specific case, but then
Yeah. I mean, you know, technically you could do a lot of things without causing issues. Okay, so where was I up to? Okay, so I've created this current. It's pointing to the head. Excellent. So now what I want to do is I want to get to the end of the list. I only have one element in my list, one node, so that makes it easy. But I need to get to the end of it. So what I do to get to the end of it is I hold a loop. And what I do is I loop through it. So in linked lists, it's easier to do while loops, not for loops, I reckon. So you might want to switch back out to whiles. So whilst current next is not equal to null. So what that condition is doing is it's checking my current and it's accessing the next element. So it's accessing this bit here and it's checking, is it equal to null? Because if this is equal to null, then what that means is you have arrived at the end of the list or at the last element of the list. What do you reckon it is? Are you sitting, so if I'm checking if current next is not equal to null, when I exit this loop, what's going to be the condition? Okay, it doesn't make any sense. So what I'm asking is, if this is my condition here, when I exit this loop, am I going to be over here or am I going to be over here? Yeah, the first one. So what it means is I'll be at this node. And the reason for that is, in this case, I want to be, if I come over here, I've gone too far. I don't know where to insert my node now because I've gone past the end of the list. So I can't actually connect anything to over here. So I need to stop on the last node, which means that my condition to stop on the last node is checking whether current next is equal to null. So whilst it's not equal to null, what I'm going to do is I'm just going to move my pointer for current. I'm going to move it to the next one. So I'm going to follow the address of the next one. So that means that when I exit out here, my current next is going to be null, and that means that I'm currently standing on this node over here. Okay, and what this line 48 is saying is now assign the value of create node data null to current next. Okay, great. So my data was 5, which means I'm sending it in with 5 and null. And back to my create node function. So if I go to my create node function, which is sitting over here, okay? So if I go to my create node function, I've sent it in with the values, what was the value that I gave it? 5, thank you. Just checking if all of you are paying attention, and null. Okay, great. So now what I'm going to do is I'm going to create a pointer, and now I'm inside create node function. I'm going to create a pointer called SPTR, S pointer, and I'm going to assign it the size. I'm going to malloc some memory for it, which means I'm going to create a piece of memory that can hold a struct node, which means it's going to have some data in it, and it's also going to have a pointer to the next item in it. Okay, and I'm going to have, let's say this is equal to 0x111. I'm going to assign this piece of memory into my SPTR pointer. So that means my SPTR right now is 0x111. It's like fun. Ben, lights off. I want to watch. I've already done Sophia today. Just taking care of all of your health today. Okay, so that means that my SPTR now has 0x111 because I've assigned the piece of memory that I have created, that I've birthed. Okay, great. Excellent. So I go on to line 64. Let me just erase these arrows because that's starting to get confusing. I go to line 64, and what I do is I access the data member of that struct, and I assign whatever data was given. So I assign 5 to it. And then I go to line 65, I access the next member, and I give it whatever was given to me as the next, which was null. So that means over here is now null. Okay? Okay, so what that means now is I have these two nodes here floating about. They're not connected in any way, but what I want to be doing is I want to be connecting them. So I'm going to return whatever the value was of this SPTR, so 0x111. I'm going to return it to where I called this function from. So in this case, over here, really starting to... So I've returned over here, and what that means is, where have I returned to? Okay, so I've returned over here, and this function has returned 0x111, which means that that's the value that I now have, and I'm going to assign it into current next. Now current was this one over here, which means that instead of null, I'm now going to assign the value that is here, so 0x111, which means that this node is now going to not point to null, it's now going to be pointing to whatever is sitting at this address. So it's going to be pointing to this node over here. So it's pointing to the new node that I've created. And then what I'm going to do is I'm going to return the head of the list. Okay, and the head of the list is 0x00, so I'm returning the address of wherever the head of the list is. So I'm going to return that into my main function. Okay, how is everyone feeling? Tom, Paul, and then maybe we'll take a little break, or should we do one more item to add to the list? Let's do one more item and then we'll take a break after that, a short break. Let's add, I don't know, let's add 13. Okay, so a few people are lost. That's okay. Let's see if you're gonna get it now, okay? Let me redraw this nicer. And just remember, linked lists, you know, it's hard. You're now playing with a lot of different things. You're playing with dynamic memory. You're playing with a whole new data structure. So it takes time, right? Don't be hard on yourself. It might take, 3-4 goes to get it. But it's all about sort of drawing it out and seeing where it's at. Okay, I'm going to draw on the bottom of the screen, I think, over here. Okay. So right now I've got something that looks like this. Okay, I've got something that looks like this. Okay, which is two nodes in a linked list that are connected. I agree, there's too many functions going on, which is making me jump around and it's making it harder to understand. I could move things into one place. How are we feeling? Do you want me to move some things into one? It's so nicely structured right now, but I think I should move things into one place. How are we feeling? How's everyone in the theatre feeling? Move things into one place? It's too much jumping around, or everyone's okay? No one's ever answers me in the theatres. Okay, Tom, poll. Can you also poll me? Oh, I'm so sorry. I haven't. Okay, I've just saved it. Okay. Move things into one place or leave it at, I mean, it's... put it all together. Oh, Ben, get out. You're kicked out of here. I feel like redoing this and adding things at the head to start with. It is much easier to explain. Yeah, I'm traversing things now as well. Hey, I'm also sweating. Like, this theatre is out of control. You told me the temperature was fine. Okay. All right. Here's what we're going to do. I'm going to rewrite this piece of code, and I'm going to make it simpler by inserting at the head each time to start with. Let's take a timeout before that. Good idea. Let's take 5 minutes, and then I'm going to redo this list and this piece of code. Okay, 5 minutes. Okay, let's switch over. right, let's get back to it. Can those online hear me all right? Maybe, yes? Yeah, excellent. Okay, so what we're going to do is we're going to redo a linked list from scratch because, again, it's a hard concept to understand, okay? So we're going to take it from the beginning, again, from the top. So exciting. And then Thursday, don't worry, we're going to catch up everything. Let's not rush. Let's just understand what's going on. Okay, so you all know what's going on here when we include the two standard libraries. If I'm going to do anything with linked lists, I'm going to build up a node. Okay, it's going to be of type struct, and I'm going to call it node because that's an exciting name to call something that is a node. I'm going to give it an int data, and then the other thing that I'm going to give it is a pointer to another node. So what that means is I have in this line created a pointer called next that points to the address of another node. Okay, so it's pointing to another struct node. Excellent. Okay, that's really going to annoy me. Oh my gosh. Okay, oh, perfect. This is why you don't do inline comments. Okay, excellent. Now, I want to be able to build up this linked list. Okay, so right now I've got nothing that will actually build it up for me. Okay, so I'm gonna do it all in main, then we're gonna move things out. Okay, because it might make more sense when it's all together. Okay, so first things first. I've got a linked list. Well, I don't have anything right now. I've got null. But what I need, if I'm going to have a linked list, is I want to have a pointer to the head of the linked list because I want to know where to start. So I'm going to declare a pointer to a struct node, and I'm going to call it head. Someone's asking in the chat, is node just the name we've given, or do we actually have to use the word node to create nodes? No, you can use whatever you want in there. But when you have a basic linked list, each part of it is called a node. It's just a term for it, but you don't have to use it. You can have it as something else. You know, it can be struct train. And as long as it's got a pointer to the next train, then you've got a linked list. Okay. Okay. So what this has done is this has created a pointer that will store the address of the head of the list. Okay. So there's nothing in it. I don't need to malloc any memory for it because I haven't actually created a node. All I have is a variable that will store an address of a struct node. Okay. Someone's saying introduce type defs. So the reason you don't do type defs in introduction is because they hide what is already very abstract knowledge. So you only do them a little bit later on. And that's why they're not done right now. Okay, so excellent. We've got a pointer to a struct node head. We now need to create nodes and do something in there. Okay, so the first thing I'm going to do is I'm going to create this node, okay? And what do I need to do to create a node? I need to malloc some memory, and then what I need to do is I need to initialize it with some values. Okay, so what I'm going to do is I'm going to create a node. How exciting. Okay, so I'm going to say struct, nope, I'm going to store it inside head. Okay, so I'm going to call malloc to create this piece of memory, and remember that malloc is a function that returns an address of where it's created this memory, so I want that address to go into head. Okay, and that's why I've got this struct node head here, so I can store the address of the node that I create in something. I could do it all in one foul swoop as well. Okay, so I'm going to malloc size off, and I'm going to malloc the size of a struct node because that's my definition of a node is struct node, and I want it to have enough memory to hold that. Okay, So what that has done is that this has created an empty node, okay, of type struct node, and placed the address of that node in the variable head. Okay, so what I have now is I've got an empty node and the address of it is sitting inside head. So now I'm going to initialize it. Okay, so I'm going to initialize the values inside the node. Okay, I only have one node right now, which means that there is nothing to point to in the next one. But let's say, for example, let's assign the value 5 to it. So my new node is sitting inside head, but that head actually has two things. So when I malloc some memory up, it created a structure that looks like this. It's got a data element, because this is my struct node, and it's got a next element. So if I want to place the value 5 in it, I need to know, and this is my head here, I need to know which element I need to access, the data or the next. Now I think you did it last week. You're not using the dot notation anymore because you have to dereference it as well. So the shortcut way of doing is to have the arrow or the stab symbol. Okay, so I'm going to go inside the data member and I'm going to assign the value 5 to it. Now my struct node has two things, so that means I have to initialize my next value as well. It's not pointing to anything, so I'm going to initialize it to the value null because it's not pointing to anything, which means that what has been created is when I assign the value 5, 5 will go in here, and then when I assign null, null will go inside here. So now I've got this one node. It's not pointing to anything, but it's got those values assigned to it. Okay, excellent. And that is my head of the list. So my list currently, in that case, looks like this. Okay. And next in this case represents the next node, the address of the next node, so I know where to go. Okay, fantastic. So I've got my new node. So now I want to do another node because otherwise I don't have a linked list. So what will I do now? I will add another node, and let's say I'm going to add it at the front. Okay, I'm going to add it at the front of the list. Okay, so if I add it to the front of the list, that means I want my new head to hold the address of this node, and then I want this one to be the next, the final item in the list. Okay, excellent. So what I'm going to do now is I'm going to create another node. Okay, and this new node, let's say, is going to have, and this is why it's easy to have functions here, because I can just call my function to create a node each time. But we will move it out like this in a second. So let's do a new node. Okay, so I'm going to create a pointer to a new node, struct node, new node, and I'm going to malloc some memory for it. Okay, so I'm going to malloc size off, and it's going to have another struct node in there, which means that what this has done is this has created another node. So in this line 27, it's created another node, got some memory for it, malloc some memory of type struct node, which means again it has the data and the next in here. It's not initialized yet, and it stored the address, whatever malloc has returned, it stored the address inside new node. So the address of it is sitting inside new node. Okay, so great. So now I have two nodes. They're not connected in any way. So let's say I want this node to have the value, 7, okay? So I'm going to assign my new node, and I'm going to go into my data element, and I'm going to assign the value 7 to it. And now what I want to do is I want to point it to, so the data 7 has gone in there, and now what I want to do is I want to point it to this node over here. What does that mean? What do you think what do you think I'm going to do then if I want to have my next pointing to this node here? What will I point it to? Head, exactly. So if I pointed to head, what that means is this is now going to point to here, okay? And what else should I do if I want to start the list over here? Because my head is still, sitting over here really. So I can also say that my new node, okay, let's go like this, okay. So now new node next is going to be to head. So that means my head really is now inside the new node. I really want to start with new node. Okay, I think it would be useful at this point in time to print something out so that you can see what is actually happening. How is everyone feeling about that? Yeah? Should we print it out? Okay, so let's print out. I'm doing it all in main. Still all in main? Can I do one function? All in main? No, okay, all in main. Okay, all in main. Let's print out a node. Okay, so I'm moving it around. I'm pointing, so head is a pointer to the first node in the linked list. And I'm putting, okay, you've just answered that. I've just read out your answer. I don't know why. Okay, great. So now, exactly, so someone is saying, isn't the head now acting as the tail of the list? Well, it is, because it doesn't really make sense now what's going on. My head is still the 5, but it's actually the tail, and my new node is really now the head, okay? So how can I say that I actually want to place, I want a new head, and I want that new head to be sitting where my new node is? How can I do that? What will I say? Yeah, so I can reassign the head. Okay, so what happens if I now reassign the head to new node? Let's see what this means if we run through it, okay? Okay, so now what I have is something like this. Okay, so I've got my head. I've malloc some memory for it. Great, here's the memory. It's placed 5 and null into it. Then I have said, okay, let me switch to a pen. Okay, so let's say the address of this one, 0x000, this is 0x111. Okay, so that means my head right now is equal to 0x000 at this point. I've got 5 in it, I've got null in here, excellent. Then I go on to here and I've got my new node, and my new node has the address 0x111 inside it. Okay, and I assign the value 7 to it, and then I say for my next, I want whatever is sitting inside head, which means it's going to have 000 inside it. And then what I've done, okay, that means I would like to reassign the address of head to the address of new node, which means that my address of head right now is going to have the address of new node. So that's now going to be 0x111. So that means my head is now pointing to the new node. So this is where the head is. And this is now no longer the head of the list. Okay, so what happens if I want to add another node to it at the head again? Okay, let's try and do that. Okay, so I've got my new node. So let me make a new, I'm going to reassign whatever's sitting inside new node. Let's see if this will work. Okay. Okay, I'm going to have malloc in here, and I'm going to actually I was going to print stuff out. Sorry, give me a second. Let's print stuff out. Okay, so I've got 2 things inside the list and I want to print them out now. Okay, I'm going to have a struct node current so that I don't lose where the head is, and I'm going to assign it the value of head. Okay, so what I've done now is I have said I'm now going to bring one more thing in, and it's going to be current pointer, and it's going to be given the value of head. So it's going to be given the address of head, and that's the one that I'm going to use to move through the list. Okay, and I'm going to say whilst current is not equal to null, which means whilst I'm not at the end of the list, whilst I'm not sitting at that very last thing in null, I'm going to print out whatever is sitting inside my list. So I'm going to print out %d, and it's going to be whatever is sitting inside current data. Okay, and then I'm forgetting to move it along, so I'll move it along as well. And I'm going to move it along by pointing it to the next one. Okay, so what happened in these two lines of code is I've created a loop that's going to keep me going until it's not equal to null. So because I can't really print out something inside null, there's no memory in there, I'm going to print out whatever is sitting inside current data. So I'm going to start at the head, which is my current. So that means I'm going to start over here, and I'm going to check, is current not equal to null? No, it's not, okay? It's not equal to null. It's got an address, which means I'm going to go inside this loop, and I'm going to print out %d, and it's going to be whatever's inside current data. So it's going to be a 7. So it's going to print out a 7 for me. And then what it's going to do is it's going to go current next. So it's accessing whatever address is inside current next, which is this address here, and it's assigning it to current, which means that I've now moved my current up to whatever was inside the next. So I've moved it over here. I'm going to go back and check, is current not equal to null? No, it's not, because there's a node here. And I'm going to print out something. So in this case, a 5, because that's what's sitting inside my current data. And then I'm going to move the current along as well, which means my current is now going to be null. So the current is now going to be sitting over here, where the null is. And I'm going to check again, is current not equal to null? It is equal to null, so I'm going to exit out of here. So let's see what it's actually going to print out for us when we compile it. Oh my God. Okay, and it has its printed, if you can actually even see what it's printed, because it's covered in red, it's printed out the 7 and the 5. Okay, in the chat, could you please let me know if that makes a bit more sense? Tom, sorry, could you please run a poll? Okay. So the reason we use that function create node is because it makes it a lot easier. Otherwise, I would just keep creating nodes inside main and it would get very old very quickly. So every time I need a node, I would just call my create node function and then just insert it wherever I want to insert it. And remember, it might take 5, 6, 10 times to hear this before it makes sense. But what I recommend you do is that you sit down and try and draw it out. Draw a diagram of what exactly is happening. It will make it much easier to understand who's pointing to who, where's the head, where's the new node, because it does get confusing who's pointing to whom. Okay, so someone's asked a great question. The head is not supposed... I can change the head if I want to insert something at the head, which is why I have changed the head this time, because I've moved the nodes around. Okay, and everything was together. Okay, what about now if I want to add a node? I guess I'll still keep going in this same horrible file without functions if it's making more sense. And what I'll do is I will add to the end of the list now in this same beautiful function. No function, in the main, which is a function, I guess. So if you understand the logic, it takes practice to make new nodes. It makes practice to build up a linked list. I'm sorry to say it doesn't happen overnight. I wish it did. It will happen, I promise. You'll hit a threshold, you'll walk through that threshold, and suddenly it will be like angels descending from the skies. Okay, so let's add a node to the end of the list. Okay, and let's do, I don't know, 9. Okay, so we've got 7, we've got 5, let's do 9, whatever. So now what I have is my current over here, because I had this loop here where I looped around until current is not equal to null. That means that when I exited this loop, my current in this case is equal to null. Okay, and this is where it's useful to never lose the head. Okay, because what that means now is I'm going to reassign the value of current. I'm going to say that current is equal to head again, which means that what I have done is I'm ready to start passing through again. So what I've done is I have said my current is now sitting over here. Okay, so this is now my current. I'm now over here. I've set it to my head. Okay, so if my current is there now and I want to add to the end of the list, what that means is that I need to go through this list and get to the last element. That means I want to get to over here and I want to add my new node at the end of the list over here. All right. Now, if I keep walking through the list until current is equal to null and I stop over here at null, that means I no longer know what the address is of this node, which means I can't link anything to it. Okay? And that means that really what I need to be doing as I go through the node, if I want to insert over here after this node, I want to stop at the node right before where I want to insert, so that I don't lose the place where it is actually that I want to be inserting into. Okay? And what that means is that it changes my condition inside my while loop. So instead of saying in here, whilst current is not equal to null, for example, which will take me right all the way to the end where current is equal to null, I actually want to stop at this last node. So the condition here is that my current next, which is whatever is sitting inside the next member of this struct, is equal to null in this case. So I want to stop as soon as my current next is equal to null. Until then, I just want to pulse through the linked list. So what this will do is it will keep me going, and when I exit this loop over here, so when I exit this loop, my current next is going to be equal to null, which means that I am sitting on the last node. Okay, so I haven't gone past the end of the list, but I am just sitting on the last node. Okay, excellent. So right now I'm at the end of the list and I want to insert something into that list, which means that I'm going to need to create a new node. So I'm going to use my new node variable again, and I'm going to create that node by mallocing some memory. So I'm going to do size of, and I'm going to do struct node. And what this will do is it will create the node for me. So on this line 48, what it's going to do is it's going to create a node. It's going to malloc some memory. Let's say this is 0x222. It's going to create a node with data and next again. It's got no value, but my new node is now going to be equal to wherever it malloc that address, so 0x222. So the pointer is now going to store the address of this new node. Okay? All right, so what does that mean now? I want to initialize some values. So I'm going to go into new node, into data, and I'm going to assign the value 9 to it. And then, so I don't have two nodes called new node, I'm just reassigning whatever new node has in it. And then I'm going to go into new node, and then what I want to do is I want to connect my new node into my linked list. So I want to go from here. So a bit of shush, bit of shush, bit of shush. My voice doesn't project that well. So I want to be now going from here to this node here. So what will be my connection now? What will be my next of the new node? So if the new node is going to be my linked list, the end of my linked list, that means that my next is going to be null because that's where I'm going to finish the list. So what I've done here is I've assigned some values. I've put a 9 over here and I've put a null over here. So I've really created a new node, and now I want to link it into my linked list. So what do you reckon I'll do now? What will be my connection? Anyone? Anyone? No? Okay, so I want this node over here to point to my new node. So what is this node? Who's pointing to this node? Which variable right now? Current, yeah? So what I want to do is I want to do my current next, which means I'm accessing this thing here. I want it to point to this new node. So what will I assign to it? Yeah, so the address of the new node. Okay, so what that will do is that will create the connection from here to here, and it will assign the address of new node, which is this address in here. It will assign it to my current next, which is in here. So that will now have the address of the new node that you want to go to. And that means that you've inserted it right at the very end. Okay, so let's try to print it out and we see if it's working. Okay, and this is why it's useful to have functions, because all I'm doing now is just the same really piece of code. Okay, so I'm going to reassign current to the head, walk through it and print out all my nodes. So let's save it and let's compile it again. And then let's run it, and it's now going to print out, so it's printing out twice because I printed it out at the start here. So it printed out the first list, which is 7 and 5, and then over here it's printed out the new linked list, which is 7, 5, and 9. Okay? So this is why it's also useful to have pointers. So if you are confused why I keep using new node, all it means is that I'm reassigning the value of new node, because once I've connected my node into my linked list, I don't really care where it is because my list knows where it is. The previous element will always know where my new node is. So I can use my new node again to keep creating new nodes. Okay, how are we all feeling? Tom, is that still running? Can people change their minds in the votes? It is fine to use whatever variable you want to create a new node. I use new node because it makes sense to me to call it a new node. You can call it whatever you want. How is this feeling? We're a little bit behind, but that's okay. We can finish. Does this look like an okay face? Thank you. Okay. Okay, here we go. I just want to see the percentages go up of like okay-ish to the other one. Should we finish with a Mentimeter? Fake Kahoot? Should we finish with a fake Kahoot? How are we feeling? Should I erase the stuff that's blocking the screen? Yeah, let's see if you can be challenged. All right, let's do fake Kahoot to finish up with, and then we will No, we're just going to finish off with this. How many people don't like my fake cahoots? I'm offended. I wrote this whilst jet lagged. Like a mass exodus. What just happened? I can see why linked lists might not make sense. It's the same question. Slightly different, yeah. I had like I don't want to see how many people have left. Why is it placed it over the top? right one. I'm not really sure why it's... Just keeping you on your toes. Take that for the win. Ah, I can cancel you, Benjamin. How do... Yeah. All right. Thank you, everyone. Feel free to leave me some feedback as well.
What did you place?
I didn't play. I'm not my friend.
I'll bring chocolate.
See you on Thursday.